Okay, this lesson is going to take the most concentration, and it's really going to hopefully internalize how all of these conic sections are organized and how they're related and what their differences are. Like I say, these are one of the more difficult things to do, so let's take this a little bit slow. One of the things that I suggest is you get a blank piece of paper and let's do a general review of all of the formulas that we have with all of these things. So push pause and get a sheet of paper and follow what I do. Okay, first of all, we have a parabola. Okay, parabolas look like, parabolas look like this. Let me go with the equation first. X minus h all squared equals 4p times y minus k. The x part here is squared. That means it will look like this. That means it'll cross, unless it might be shifted so it won't, but the basic parent one will cross the x-axis 2 times. So that means it's up. Now, that's when the p is positive. It will go up. If p happens to be negative, it will still cross the x-axis twice, but it will go down. That's when p is negative. So it has to do with this number right there. Okay, but they could also look like this. It could be y minus k all squared equals 4p x minus h. See, this one, the y is the one that is squared. That means it's crossing the y-axis twice. Now it opens to the right when p is positive. It opens to the left when p is negative, like that. Okay, this h and k. H and k is the vertex. Okay, so whatever h and k is, that's where the vertex is. The focus is this p number, so let me put one in there. I'll put the focus on the inside like that. Okay, there's a focus and then the same distance, so this is the p number right here. That is p. The distance from the vertex to the focus. And then p also is the distance to the directrix. So that is also p. So p gives you two things. Parabolas have a balance between the focus and the directrix. Okay, the directrix is just a straight line, and what the directrix does is, if you put any point on the parabola, I'm just going to call that a point, the distance to the focus and the distance to the directrix, let me put it up a little bit further, is the same. That distance and that distance are the same. So we have a directrix, and then we have, let's see, we have the point to the focus. That distance is equal to the point to the directrix. We'll write it something like that. So those are some of the things that we know about parabolas. Okay, then we went on to a circle. This is probably the easiest one. Circles are x minus h all squared plus y minus k all squared equals the radius squared. So again, the center is at hk. And the radius is just the square root of that. So that number will have to be square rooted and it will be the radius. Okay, so these basically look like, I mean, you have a center and then you have a circle around. It creates a circle. The thing that we know about this is all points are the same distance to the center. So if I put a point right there, that distance, and then if I put another point right there, that distance, of course, are the same. It's the definition of a radius. So all the points are the same distance to the center. Then an ellipse comes around and stretches that. So this one is always equal to the radius. An ellipse divides by this number, and it puts each individual radius on the bottom of each axis. So it could look like this: x minus h all squared over a squared plus y minus k all squared over b squared, and then it's equal to 1. Okay, that looks like this. That kind of an ellipse, let's say we have a sideways one going like this. Okay, here's the center. The x-axis, that one under the x number, that's the a distance all the way to that vertex. Whatever under the y, that's the b distance right there. So it's elongated this way when a is bigger. So this happens when a is the larger of the two. Okay, it could be like this. There's the center. Now the x is short and the y is long. So it looks like this when a is smaller than b, when b is bigger. Okay, these also have a focus. In fact, they have two focus. Let me draw another one right over here. Here's the center. The focus would be there and there. Okay, that's C. I'll put it right here. Let's say this focus is right there. The distance from the center to the focus is called C. Okay, so here's the relationship. If we put a point anywhere on that ellipse, the focus point, focus 1 plus the distance to focus 2 always adds up to the long axis, which, since this little bit is A and this little bit is A, we say the focus 1 to the point plus the focus 2 to the point is equal to 2A. That's one relationship that we have. Another relationship that we have is a squared, the a squared number, minus b squared equals c squared. That relates these three distances together. Now you always put the bigger number first because we want it to be positive. So here it would be, if it was this way, it doesn't matter the letters. It's the bigger one minus the smaller one equals the focus one. And then again, the center here is at HK. So there are some things we know about ellipses. And then we have hyperbolas. A hyperbola is the same thing, only instead of being added together, it was stretched so far that it broke apart, and so now it's one of them is imaginary. So now we have x minus h all squared over a squared minus y minus k squared over b squared equals 1. So the only difference is that that piece right there is minus. What that means is the vertex on the y-axis is imaginary. Of course, it could be the other way around. The y part might be positive. It might be y minus k all squared over a squared minus x minus h all squared over b squared equals 1. If it's like that, now the negative is on the x. That makes the vertex on the x-axis imaginary. So what those pictures look like is something like this. Okay, here the y vertex is imaginary, so that's going to be an imaginary vertex, and so is this one. But the x's will be real, so that one and that one will be the real ones, and we draw this little box around there to kind of help. And there's asymptotes that go through the box, and now the real ones are the ones that hold the shape. So the real vertex is the ones that are touched. So it ends up looking like that. This one, if the x's are imaginary, okay, that's saying that this is the imaginary one and this is the imaginary one. And it makes this one real and this one real. So when we draw the box, it goes this way. It touches the real vertex, not the imaginary vertex. Okay, so what do we have here? Let's talk about what A, B, and C is. So the focus is always on the inside of the curve, so the focuses are there. Here's the center. Okay, the A number, it's the same as it was before. The A number is from the center to the vertex, so that would be A right here. That distance would be A. That distance now is B. So A is the center to the vertex, B is the center to the vertex, even though it's imaginary, and then C is the distance to the focus. So it's just like in the ellipsis, but now for the focus we have A squared plus B squared equals C squared. So the signs are just the opposite. Ellipses are plus, but the focus relationship is minus. Hyperbolas, the equation is minus, but the focus relationship is positive. We have the center at HK again. This one also, we have to come up with equations of these asymptotes. So for the asymptote, in the equation, we can do it in point slope form. It'd be y minus wherever the center is, which would be at K, equals the slope, x minus wherever the center is, which would be at H. Now this slope we can get from the asymptotes because this point and the corner of that box are on the line. So it's up and over. That must be the slope. Well, look, the up is the B distance and the over is the A distance. So that slope is always B over A anyway. And then what's happening with a point here is like over here, if you put any point on the curve, the focus to the distance, focus point adds up to the major axis. It's similar here. Any point to the on this curve, I'll put it over here. Let's say I put a point right there. Okay, so if the focus here would be about there and the focus would be about there. Okay, the distance to that focus and that focus, so those two distances. Focus 1 to the point and focus 2 to the point. If you take those and subtract them together and then just take the positive number of that. So if I subtract those together, now that equals 2A. And remember what A is. A is the distance to the vertex. So again, 2A, basically it's the distance between the vertexes. A and A, it's how far apart the vertexes are. So now, on a point, if we subtract those two distances, that's always how far apart the curves are. Okay, those are things that we know about conic sections. We'll refer to this page. I'm going to let you have this page on the test so that you can have a reference to what the formulas are. Okay. Let's take a look now at writing equations. They're telling us that this is a parabola. Okay, they're giving me a vertex and a focus, and that's all. And they want us to write the equation for that. Okay, so I know from my sheet over here that this is the formula for a parabola. So I am going to get a visual of this first. So let's see if we can't draw a quick little sketch of what's happening. Okay, it doesn't necessarily have to be to scale, but here's the vertex at -10, so way over here, and -8, somewhere right there. There's the vertex at -10, -8. Okay, and then the focus is at -10, okay, what is that, 8.5? Okay, so -10, so it's down a little bit, so I'll exaggerate. So there's my focus point at -10, -8.5. Okay, the focus is always on the inside of the curve, so that must mean it's looking something like this. Okay, so which shape is that? See, that's the kind that if it was not shifted, it would have crossed the x-axis twice. It's that shape. Okay, so that means it's an x squared. So that's how I now know this is an x minus h squared situation equals 4p y minus k. So that's how I know, by taking a look at it, I know which equation to use. Okay, This is the vertex. That's the h and the k. So I already have x minus 10 all squared, and then 4p y minus 8. So now I got to see if I can't figure out what this p thing is. Okay, well, when we go take a look at our reference, p is the distance between the focus and the vertex. Okay, that's this distance right here. Well, this was down, the vertex is down 8 and the focus is down 8.5, so that must mean the p is 1/2. And since it's pointing down, it's actually -1/2. So if I put -1/2 right there, I have 4 times -1/2. So now we have x plus 10 all squared. 4 times -1/2 is -2, y plus 8. Okay, that's the standard form. It's not supposed to stay standard form up here. It's supposed to say general form. And general form is this thing all multiplied out. So let's go ahead and multiply this out. So to square all of this, it's the first one squared, double the middle, so 10x doubled, and then the last one squared, and then -2y minus 16. Okay, these equations are typically let's see, typically solved for y. That's what general form is. I had to think about that for a second. This one would be solved for y so that we could put it in our calculator. So let's see. How about, first of all, I move the 16 to the other side. Okay, so now we have x squared plus 20x, so plus 116 equals -2y. And I'm going to divide everybody by -2. So we end up with y is equal to -1/2 x squared. 20 divided by -2 is -10x, and 116 divided by -2 is -58. Okay, if we put that in our calculator, we will get a vertex at -10, 8, and it'll be pointing down. This one is easy to show on the calculator. They're not all easy to show. If we go -1/2 x squared minus 10x minus 58. Okay, so I better get a window that will hold the -10. So I'll make my window go to -20, 10, maybe -20 down, up 10. That should do it. Okay, there it is. I could probably just go take a look at the table to see. So the table over here at -10, we can see is -8. Yeah, what class do you have right now? What class? Okay, yeah, you can have that. Okay, so there, and we could look at the focus, but it doesn't show the focus very well on this. It doesn't show the focus because the focus is actually not one of the points of the parabola. The focus is right there. Okay, so there's our first one. Okay, let's try number 2. So you just have to see, they don't always give you the same information. They give you things to try to fill in these spots. So let's get it. I need a picture of all of them. So let me get a picture of this one. Let's see, I think I'm gonna think of this more as a decimal, so that's more like -725, and 27 divided by 4 is -675. Okay, just so that I can graph it a little bit quicker. Okay, so here's the focus, -725, -7. So now this is the focus. Okay, the directrix, okay, that means it's crossing the x-axis at -675. So this is right there is -725, so -625's got to be somewhere right here. Okay, so that's at negative 675. Okay, so the directrix is, so halfway between the focus and the directrix is the vertex. I'm going to scratch that out a little bit and put a dot there. There's the focus. That's going to be the vertex, halfway between them. So that means this thing's curving like this. Because the P number, the P number is that little distance there and that little distance there. So that means the vertex has to always be halfway between the focus and the directrix. And since that's what they gave us, it's a good way to find the vertex. So the vertex is halfway between those things. Well, let's see here. Well, we already know that it's down 7. So I know the vertex is down 7. It's going to be on the same depth as those. And then it's going to be halfway between this point, which was negative 725, and this point, which was negative 675. So I just need to find halfway. Negative 725 plus negative 675 cut in half. Halfway is you just add them up and divide by 2. Or you can probably do this one in your head, but if not, negative 725 plus negative 675, cut that in half. It's negative 7. Negative 7 is halfway between there. So there's the vertex. That vertex is at negative 7, negative 7. The reason I drew the picture is because its parent shape was like this, where it would have crossed the y-axis twice. So that means it's the y that is getting squared. Okay. Now I just got the vertex. They both are a 7. You can't really mess that up. So it's going to be y plus 7 all squared equals 4p x plus 7. And now that little p distance, so the vertex is at right in between there, is at negative 7. Okay, well if I go this way, so we go to negative 725, I can see that p is equal to 0.25. Or if I go the other way, negative 7 to 675, it's 0.25 that way also. So the P number is 0.25. Well, 4 times 1/4 is 1, so we have y plus 7 all squared equals 1 times x plus 7. Okay, there it is. All I really have to do, oops, I forgot. It's pointing to the left, so it's actually negative 0.25 because it's opening in the negative direction, so it actually makes that a negative 1. Okay, let's square this out. Now we have y squared, double the middle, so that's 14y, and then 7 squared is 49. Put the negative 1 on there. Now for this kind, we typically solve it for x. So, I don't know. I guess I'll just move the 7 to this side. So we have y squared plus 14y plus 56 equals negative x. And divide everybody by a negative. So negative y squared minus 14y minus 56 is equal to x. Okay, so there's a couple different things. See how being given different information really forces you to understand what P is and understand what which direction it's going. That's the point of these. Okay, let's try number 3. Okay, so 3 is a circle. Now they want us to write the equation, the general equation of a circle. Okay, so I'm going to switch over to, let me remind myself, what is a circle? A circle's got the center in it and the radius squared. Well, let's see what they gave us here. The ends of the diameter. Okay, I need to draw that. Negative 9, 14. So negative 9 up 14, somewhere around there. Negative 9, 14. And then negative 7, 16. So it'll be a little bit shorter, but taller. I'll put it right there. Negative 7, 16. And that's the ends of the diameter. So when I draw my circle around that, it's going to look something like that. Okay, if those are the ends of the diameter, the center will be the midpoint of that. So I just need the midpoint between those two dots. Okay, well the midpoint is x plus, it's the average of the x's, and then it's the average of the y's. Like what we just did over here when we had to find halfway. I need halfway. You add them up and divide by 2. So the center here is going to be at -9 plus -7 over 2. And then it's going to be at 14 plus 16 over 2. So it's halfway between -9 and -7. So our center is at -8. That adds up to -16 cut in half. And this is 30 cut in half. So there's our center. Well, that's pretty much all you need for this kind of equation, because this equation is x minus h squared plus y minus k squared equals the radius squared. So we have most of it. We have x plus 8, that's coming from this, and then y minus 15, that's coming from the 15. Now I just need the radius. Okay, well the radius would be that distance right there. Well, you got a couple choices. We can either find the distance between the diameter and cut it in half, or we can find the distance between the center and one of the edges. They'll both be the same because the points, we can go to the top edge or the bottom edge. So the distance formula. The distance is x minus x all squared plus y minus y all squared. Okay, I think I'll just go between these two, the 8, 15 and the -9, 14. So the distance is going to be the square root of -8 minus -9 all squared plus, and then the y's will be 15 minus 14 all squared. So that's -8 plus 9. -8 plus 9 is 1 squared is still 1. And here 15 minus 14 is 1 squared is still 1. So the distance is the square root of 2. That's the distance from the center to the edge. Okay, so that's the radius, the center to the edge. Okay, the radius is squared in the formula, so I need the square root of 2 squared, which is 2. Okay, now all we have to do is multiply it all out, and we have this equation. So this piece, first term squared, 8x doubled, and then the last piece squared. Here, the first piece squared, -15y doubled. -15 times -15 is positive 225 equals 2. Now you don't solve these for a letter typically. We just put it all in order and set it equal to 0. So we put it in alphabetical order, highest power first. So x squared. Then the next thing we have is a y squared. Then we go to the singles, so single power, so that'll be the 16x, and then the minus 30y, and then I'll subtract this 2 over there. So I have 64, 225, and -2. $287. And there we have it. Okay, number 4. All right, now they're giving us the center. Well, I'm going to draw it anyway. Over 3 up 11. So there's my center at 3, 11. And then some random point on the circle is at -4, 9. So it must look something like this. The center and some random point. Well, the center, that's already half done. X minus the x all squared, and then y minus the y all squared equals the radius squared. Right there's the radius. I just need to find that distance. So if I find that distance, that will be the radius. So the distance there is the square root of, okay, negative 4 minus 3, x minus x squared plus the 9 minus the 11, y minus y. So that's negative 7 squared, so that's 49. That's negative 2 squared, so that's 4. So the distance, which is the radius now, is the square root of 53. So when I square it, I'll put it in there as a 53. So we have x minus 3 all squared plus y minus 11 all squared equals 53. Square this out. First one squared, 3x doubled, negative 3 times negative 3 is 9. First one squared, negative 11 doubled is negative 22y, and 11 squared is 121. Okay, put it in order. X squared first, then the next highest power alphabetically is y squared, then the negative 6x comes next, and then negative 22y comes next. Move the 53 over, and I have 9 plus 121 minus 53. 77. And there is the equation of that circle. Okay, now let's take a look at number 5, and now we're dealing with ellipses. And then we want the general conic equation. Well, let's check out our ellipse formula. It's either going long way this way or a long way up and down. Going to have a long radius and a short radius, and we still have the center, and it's all going to equal 1. Well, let's see what they've given us here. Okay, again, I'm going to need a picture. So 3, 4, 1, 2, 3, 1, 2, 3, 4, right about there. There's one of the vertices. And then negative 9, 4. Okay, so that one's at 3, 4. This one's at negative 9, 4. Okay, we've got some kind of a focus here. Notice that the focus is holding the center, no, it's not. Let's not notice that. Well, let's find the center. How about that? So this is a vertex and this is a vertex. The center is going to be halfway in between there. Okay, so halfway in between there. So the center is going to be halfway between these 2 points. So I'll do the x's again. Negative 9 plus 4 cut in half. Plus 3, the x's cut in half. And then the y's will be 4 plus 4 cut in half. So the center is at, what do we have here? Negative 3, 4. Okay, now let's notice that. So the focus, so this is some kind of a ellipse looking like this. Now, I wasn't sure if it was up and down, but the focus is always on the inside of the shape. And look at this focus. You see this focus? Here's the center, and it's going to the right 2 square roots of 5. Here's the center, and it's going to the right 2 roots of 5. And then here's the center again, and it's going to the left 2 roots of 5. That's this one. That's what that's telling us. That's telling me that the distance from the center to the focus is 2 roots of 5. Well, that's something handy. That's the letter C when we do the focus thing. The center to the focus is C. The center to the vertex is A, and we actually can figure that out. The center's at negative 3, and it goes over to negative 9. A is 6. That distance is 6. That distance is 2 roots of 5, and it's the B distance that's missing. Okay, so we have a lot of information now. We have the center. That's at least some way to get started. We have x plus 3 all squared over something. X plus 3 all squared over something. And then I have y minus 4 all squared over something, and it's all going to equal 1. These somethings are how wide the x-axis is. It's right there. That's how wide the A number is. The X radius is 6. So that's a 36 down there. The Y radius is unknown so far, so we got to figure that out. We do that with the focus formula. The focus of an ellipse is a squared minus b squared equals c squared. Okay, you take the bigger one and subtract the smaller one. The bigger one is 36. And then the c squared is 2 roots of 5 all squared. That 36 came from 6 squared. I guess that was that number squared. So 6 squared is 36. Okay, that's a 4 and that's a 5. So it becomes 4 times 5. So it's equal to 20. So negative b squared equals negative 16. I just moved the 36 over there. So b squared equals 16. That must mean that distance right there is 4. Okay, so here's our equation. I'm going to go ahead and square this out now, and that became 36. There's our actual equation. Now we just need to put it into general form, flatten that thing out. Well, let's multiply through by the common denominator. Now, you could multiply through by 36 times 16. We could multiply everybody by 576. If we multiply by 576, 576, 576, but that's not going to, then I'll have to shrink it down to the least common denominator. Let's just start with the least common denominator. Now, how the heck do you find the least? I need a number, the first number that both of these multiply into. It's called the least common multiple. Okay, here's how you do it. You probably learned this back in the 5th grade, but I'm sure you have forgotten. Split this into its prime factor. So take 36 and divide it by anything that makes 36. So 6 times 6 is 36. Then divide that. That's 2 times 3. Okay, those are prime factors. Those don't go any further. And this is 2 times 3. So 36, there they are, that's the end, is 2 to the second times 3 to the second. Okay, let's do that with 16. 16 could be 4 times 4. And of course, those are 2, 2, 2, 2. So 16 is 2 to the 4th. Okay, here's the least common multiple. You take the biggest of all of these. So you look at the 2's and you take the biggest one. So the least common multiple is the biggest one. That's 2 to the 4th. Times, then you go to the next one. Who has the biggest 3? Well, this one does. 3 to the second. And then if there was another one, we'd keep going until we had all of the biggest ones. Okay, so this is 16 times 9. 16 times 9 is 144. Both of these will divide into 144. Okay, so I'm going to multiply this by 144. I'm going to multiply this by 144. I'm going to multiply this by 144. 144, 36 will divide into 144. It divides in there 4 times, so this can reduce that to a 4. 16 will also divide it, so 16 will reduce that down to a 9. So here's what we have. We have 4x plus 3 all squared from this piece. Here we have 9y minus 4 squared from that piece, and now it equals 144. Okay, let's multiply all this out. We've got to do the square first. So I have x squared, 3x doubled is 6x, and then 3 squared. I have y squared, negative 4y doubled is negative 8y, and then plus 16 equals 144. Multiply in the 4, so now I've got 4x squared plus 24x plus 36. Multiply in the 9, plus 9y squared minus 72y plus, I think that's 144. Yes. Equals 144. Okay, well, I'm going to set it equal to 0. So those are actually going to go away. So putting it in order, 4x squared, the alphabetically highest power, Then the next alphabetically highest power is 9y squared. Then alphabetically the next highest power is 24x. And then minus 72y. And now I had 36 and then negative 144 and 144. So all I have left is that 36 equals 0. There is the equation of that ellipse. Okay, it's a lot. That's why I said these take a lot of concentration. Okay, let's do number 6. Okay, so we're dealing with an ellipse again. So let's see, co-vertices means the short ones. Vertices, if it just says vertices like here, that means the long, over here it said the vertices, that meant the long ones. So what the next one's giving us are the two short ones. Okay, well let's take a look where they are. Okay, 1, negative 2, and negative 9, negative 2. Now, since it says that those are the short ones, that means this is a long one like this. Okay, but now the center is still halfway in between there, so the center is still going to be right there. So let's see if we can't find the center. Center is going to be halfway, so our center is going to be halfway between these. So 1 plus negative 9 cut in half, and negative 2 plus negative 2 cut in half. So there's our center. Negative 8, so negative 4, negative 2. So that's that dot right there. Negative 4, negative 2. So that gives us some things. That gives us this distance right here. If this one's at negative 4 and this one's at positive 1, that must mean that distance is 5. Okay, that's the B distance. Let's go ahead and start writing some of this down since we have the center. I have x plus 4 all squared over something, which I already know what it is. The x number is 5, so it's going to be over 5 squared. Plus y minus negative 2, so y plus 2 all squared over whatever it's going to be. That's however tall it's going to be. That's going to be this distance equals 1. Okay, well let's see if we can't figure out that distance. They gave us the focus points. It's going over negative 4, and then it's negative, so notice it's at the negative 2, and then it's going up 5 roots of 3. So that focus point is starting at the negative 2, and then going up 5 roots of 3. And then the other focus is starting at negative 2 and going down 5 roots of 3. So that's the C number. The distance from the center to the focus is C. So C must be 5 roots of 3. We know this one is 5. Okay, and A is all the way. So that's what A is, and that's what we're missing. That's what's going to go right here. Okay, so we take the big one. So for the focus, we have A squared minus B squared, which is 5, equals C squared, which is 5 roots of 3 all squared. So I have A squared minus 25 equals, so that's 25 times 3. Add the 25, so I have A squared equals 100, so A is 10. So this distance right here must be 10. So it goes right there. That's the y distance. That's what the focus formula is for. Okay, so I'm going to go ahead and just scratch this part out now. 5 squared is really 25, and 10 squared is really 100. So I'm just going to multiply by the common denominator. It looks like it will be 100. So if I multiply by 100, multiply by 100, multiply by 100, that reduces itself down to 4. That reduces down to 1, and that becomes 100. So what I'm left with is 4x plus 4 all squared plus y plus 2 all squared equals 100. If I just multiply that out, we have this one done. So the first term squared, the middle term doubled, that's 4x doubled, so 8x, and then the 4 squared. The first term squared, double the middle, 2x doubled is 4, or 2y doubled is 4y, and then the last one squared is 4. Multiply in the 4. 4 times 8 is what, 32. 4 times 16 is 64. I'll move the 100 to that side, so this will be minus 100, and put it in order. 4x squared, and then a y squared. 32x, 4y, and I've got 64 plus 4 minus 100, so 68 minus 100. Negative 32. And there is number 6. Okay, I need to split this video here because I have some kids coming in, so I'll make a second video for these last two.